So today we'll be covering the Finding the Odd One Out guide, which covers how to solve these Finding the Odd One Out questions. So to start, let's talk about the basic structure of these questions. In each odd one out question, you will be presented with a set of elements, typically consisting of between 4 and 6 shapes or patterns. All but one of the elements will share a common feature or will follow a specific rule. And your task is to identify the element that does not conform to the rule followed by the others. So in other words, the key idea here is that you are looking for the only element that fails a rule that all others satisfy. So now let's talk about the most important rule for solving these odd one out questions, which is the uniqueness test. So odd one out questions have one main trap, and that's that a feature can be unique and still be useless. So it's not enough that an element has a unique value. You must find a feature that creates a clear majority pattern, where the keyword here is really majority, as we'll see through the rest of this lesson. So for example, all are the same and one is different, or all are odd and one is even. So to understand this better, let's take a look at an example of a bad or invalid unique feature. So for example, let's say we had 4 elements. So first, I'll just draw these 4 rectangles to represent our 4 elements. And let's say within each of these elements, we had a different number of small shapes or dots. I'll use dots to keep it simple. So in element 1, we had 1 dot. In element 2, we had 2 dots. In element 3, we had 3 dots. And you guessed it, in element 4, we had 4 dots. Well, in this case, then every element has a unique number. Element 1 has 1 dot, element 2 has 2 dots, and again 3 has 3, and 4 has 4. So you cannot choose any element just because its number is unique. They all have unique numbers. And for the same reason, picking the one with the most, or least, is usually invalid as well. If there is one element with the most components, in this case element 4 with 4 dots, then there is also an element with the least components, which of course is element 1 with 1 dot. Both in this case are special, so the rule does not produce a single intended odd item. So what you must find instead is a feature that produces a clean split, with all but one element sharing the same property and exactly one element that does not share it. Now let's look at some examples of a valid majority plus one exception rules. So again, these are examples that would pass the uniqueness test. The first is all are odd numbers and one is even. Here is the majority, all are odd, and the one exception is that one element is even. A second example, all have straight edges, this is the majority, and one has a curved edge, this is the exception. Similarly, all have vertical symmetry and one does not. All contain an inner shape, one is empty, and all are upright and one is rotated. Now again, these are just examples. There are many other examples that we could think of, and we'll see some of these in some upcoming examples. Now let's take a look at a visual example of the uniqueness test. And this example will show why a feature being unique is not enough. A valid rule must describe all but one figure. So if your rule produces 2 special candidates, or a 2 versus 2 split, for example, then it fails the uniqueness test. So the first failed rule we'll take a look at is color. So if we look at our elements, we see that elements B and D are both filled with white. Then C is filled with black. However, A also stands out compared to B and D. It's filled with gray. And therefore, neither A nor C is unique, and the color rule does not pass the uniqueness test. Next, we can look at failed rule number 2, which is shape type. Now here, we see elements A and D both have circles. Then B contains hexagons and C contains squares. So if you try shape type, then you get 2 candidates, so it also fails the uniqueness test. Next, we have failed rule number 3, which is the number of shapes. Reviewing our elements once more, we see that element A has 2, B has 3 shapes, C has 3 shapes as well, and D has 4. So if we chose most shapes and therefore selected D, this is not valid because therefore there is also a least shapes, which is A. And this is what we discussed on a previous slide. This would create 2 special candidates, and this would not pass the uniqueness test. Also, we can notice that B and C contain the same number of shapes. They both have 3 shapes. So 3 shapes is not unique anyway, and once again, this does not pass the uniqueness test. And this brings us to the valid rule, which is position. And this indeed does pass the uniqueness test. We see that in elements A, C, and D, all of the shapes in each element are placed away from the corners. None of them occupy a corner. If we contrast this with element B, we see that the 3 hexagons are all placed in the corners of the frame. We see that we have 1 in the bottom left corner, 1 in the top right, and the 3rd in the bottom right. So this indeed produces a clean split. We have 3 figures follow no corner placement, and only 1 violates it, which is B. So in this case, B would be our correct answer. B is the odd one out. So now let's take a look at a reliable method that you can use every time to solve these odd one out questions, which starts with step 1, which is to look for a majority rule. You should ask yourself, what do most of these share? Remember that you're aiming for a rule that creates a split like 3 versus 1. Or if you have 5 total elements, 4 versus 1, 6 total elements, 5 versus 1, and so on. Step 2 is to state the rule in one sentence. You should keep it simple and testable. So for example, these have straight edges. These contain an interior pattern. These are vertically symmetric. And remember, complexity may actually be an indicator that you're missing something, so it should be kept simple. Step 3 brings us to the uniqueness test, which is a mandatory step of this process. You should confirm that the rule fits all elements except for 1, only 1 element fails it, and no other option stands out based on a variation of the rule. If the uniqueness test fails, then it is not the intended rule yet, or it is incomplete. And then lastly, step 4, refine once if needed. If your rule produces more than 1 odd candidate, then add 1 additional feature and retest. So with that, let's apply this process to our example here on the right. In this case, we have 4 elements. We have element 1 with a triangle. Element 2 has these 2 nested squares. Element 3 has these 3 nested hexagons. And element 4 is simply a circle. So again, ask yourself, what do most of these share? Well, you might be tempted to hone in on the number of shapes or the number of nested shapes. So if we take that view, we have a triangle with 1 single triangle. Element 4 has this single circle. Element 2 has 2 squares. And element 3 has 3 hexagons. So even though we have 2 shapes present, 2 squares in element 2, and 3 shapes, 3 hexagons in element 3, these are both unique. So there's no majority rule based on the number of shapes, or the number of nested shapes. So this would be incorrect. Now, to point us to the correct pattern, we can consider that all shapes but 1 have straight sides. Element 1 has straight sides with this triangle. Both of the squares in element 2 have straight sides. All of the sides in these 3 hexagons in element 3 have straight sides. but the circle does not have straight sides. So if we move on to step 2 and state the rule in one sentence, remembering to keep it simple and testable, we can say all shapes except for one have straight sides. Then, if we want to run the uniqueness test, let's confirm. Is it true that the rule fits all elements except for one? Yes, it fits all elements except for this circle. This is the only element without straight sides. Is it true that only one element fails it? Well, yes. Again, it is just this circle that fails the majority pattern of them all otherwise having straight sides. And lastly, no other option stands out based on a variation of the rule. This is also true. So this does pass the uniqueness test, and we don't have to move on to step 4. There's no need to refine because we've satisfied the uniqueness test. And therefore, element 4, the circle, would be the odd one out. So sometimes with these odd one out questions, it won't be too difficult to identify the relevant feature that forms the majority pattern and therefore the exception. But sometimes it's not so obvious. So here we have a feature checklist that you can familiarize yourself with so you know what to look for when looking for the odd one out. So first we have curves versus straight edges. And this is what we've seen in that previous example. We had 3 elements where we had shapes that all contained straight edges, and we had one element that was a circle which did not have straight edges. Then we have symmetry, where there can be vertical, horizontal, or rotational symmetry. We also have orientation, so upright versus rotated or mirrored. Containment and nesting. This we also saw in our previous example, but notably, it did not contribute to forming that majority pattern. So there can be inner shapes, frames, layers, and so on. Then we have fill, texture, or color. So it can be blank, dotted, striped, or solid. We have intersections and overlaps. So it can be touching and crossing versus separate. And then we have component types. So all the same shape versus one different shape. And then lastly, we have count. And you should use count very carefully, as it often fails the uniqueness test, as we've seen previously. So again, this is something that you don't necessarily have to commit to memory, but the more familiar you are with these features and the more you have this checklist ready in your mind, you can more easily identify the features that are relevant to the odd one out question that you're working on. So now let's talk about some of the most common logical mistakes when solving these odd one out questions. And the first mistake is choosing the most or the least. We've already talked about this a little bit, but it's such a common issue that let's cover it one more time. So again, this mistake usually produces 2 special candidates, so most and least, which would fail the uniqueness test. And the fix, in general, is simple. You should prefer rules that create a clear majority category. So for example, all are symmetric and one is not. And below we have an example. So C stands out for having the fewest sides, where E stands out for having the greatest number of sides. Now, since both fewest sides and most sides both create an outlier, that approach fails the uniqueness test. So instead, a better majority rule is based on vertical symmetry. So if we look at A, C, D, and E, all of these shapes in these elements are vertically symmetric. And to clarify what I mean, if we were to draw a vertical line through each of these shapes, we can see that if we reflected each half onto the other, it would map on perfectly. There would be no difference once we did so. Now, if we compare that to B, we draw the same vertical line, and then we reflect one side to the other, well, that's not vertically symmetric. So this does pass the uniqueness test. It's a clear majority rule. All but one follow this pattern, and therefore B is the odd one out. So a second common logical mistake is overcomplicating the rule. And this is also something we've touched on already, but again, it's a very common and problematic logical mistake, and therefore let's cover it one more time and take a look at another example. So remember, if your rule needs a paragraph, then you're probably forcing it. You should be able to articulate the rule simply and concisely. And the fix for this mistake is to switch the feature category and look for a simpler majority rule. So let's take a look at our example here. Now, there seems to be a lot going on, and you might be tempted to build complicated rules about which shapes can sit next to each other, whether shapes are 2D versus 3D, or which shapes are curved versus straight. That's slow and often leads nowhere. So the simple majority rule is the number of different shapes. So let's count. In element 1, A, we have 3 types. We have hearts, triangles, and squares. B also has 3 types. It has circles, cubes, and hearts. C has a different number compared to A and B. It has 4 types: cubes, squares, triangles, and hearts. Let's continue. D also has 3 types: cubes, triangles, and circles. And lastly, E also has 3 types: hearts, triangles, and squares. So C is the only element with a different number of types of shapes compared to the rest. So therefore, C is the odd one out. A third common logical mistake is stopping at the first difference that you notice. The first visible difference is not always the intended rule. And in fact, sometimes it's actually there intentionally to mislead you. And the fix, again, in general, is simple. And that's always remember that there must be a clear rule. So if we take a look at our example, let's see what we notice. Well, it might be tempting to choose C because it's the only element where a square is the outer shape. But that fails the uniqueness test because D also has a unique feature in a different way. It's the only one with a circle as the innermost shape. And remember, when you can find multiple unique claims, then you have not found the intended rule. So let's return to that fix and remember that there must be a clear rule. So the correct majority rule is the set of 3 shape types used across the layers. So in A, C, D, and E, in different orders, the 3 layers are made from 1 circle, 1 square, and 1 diamond. Each appears once, again in different orders, but they're used exactly once in each element. Now, if we compare that to B, we see that there are 2 squares and 1 circle. There's no diamond included in this. So for this reason, B is the odd one out. So the fourth and final common logical mistake we'll cover is it's unique, so it must be the odd one. So this is wrong when multiple elements are unique in different ways. And the fix is to accept a rule only if it creates one exception and all others match. So once again, let's take a look at the example below. Now, at first glance, it looks like A is the odd one out because it's empty. In other words, there are no bold lines and no dots. Similarly, D can also look special because it's full, or in other words, it has the most bold lines and the most dots. But be careful, because actually both of those are distractions. The majority rule is the relationship between the number of bold segments and the number of dots. So let's go through this one at a time, element by element. So if we look at A, there are 0 bold segments and 0 dots. So it matches. The number of bold segments and the number of dots matches, which in this case is 0. In B's case, what do we see? We see 3 bold segments, and I'll highlight them so we understand exactly what we mean by bold segments. We have these 3 bold segments, and then we have 3 dots. So this matches. 3 bold segments, 3 dots. It's the same relationship. We'll skip C for a moment. Hint, hint. In D's case, we see 4 dots. 1, 2, 3, and 4. And likewise, we see 4 bold segments. And then lastly, in E, we see 2 dots and 2 bold segments. So all elements except for C have a match, because in C's case, we have one dot, but we have two bold segments. So this is not the same relationship that we see in all of the other elements, and therefore the odd one out is C. And with that, this concludes our guide to solving odd one out questions. So remember, to succeed, you should keep these logical mistakes in mind. You should familiarize yourself with the checklist of features so you know what to look for, and master the uniqueness test. And together, with a little bit of practice, you will become a master of these questions too.